and welcome to an overview of the VRV plugin for IES's virtual environment software. The virtual environment, or VE software, is a powerful market-leading thermal analysis tool used in architectural and consulting practices worldwide, and it aids the design of buildings from an energy point of view, which not only includes the performance of the construction materials for the building fabric, but also includes analysis of how that building is used and the systems that service it. Since Daikin were the first to launch VRV systems in 1987, the technology and importantly the efficiency of the systems has grown exponentially, offering those responsible for buildings a more efficient, less costly and more environmentally sound solution for the accurate control of the air temperature within the building. And by using Daikin's heat recovery VRV systems, it's possible to reuse waste heat in other areas of a building, or even to store that heat in water for use as domestic hot water for sanitary purposes, or for underfloor heating, or for areas where heat is required when other parts of the building may require cooling. Daikin UK have partnered with IES to produce a plugin that sizes the correct VRV equipment for the building and also performs an accurate energy simulation of Daikin's VRV systems. By using this plugin, it is possible to get higher than the published efficiencies for these systems, allowing for more flexibility within a building's design and helping to achieve or improve upon the building's target emission rates. This introduction is designed to give you an overview of the capabilities of the plugin and show you how, by using VRV equipment, it is possible to obtain very high efficiency HVAC solutions to aid with compliance for Part L of the building regulations. To start, we have a small model of a restaurant. This model is based around a building contained within Daikin City. And for the sake of this demonstration, we will be concentrating solely on the ground floor. Assuming that all of the shading has been calculated, the building constructions have been assigned, along with the usage patterns of the building. The next step is to create the VRV systems that will supply the temperature control in the Apache application within the virtual environment. Included within the module is the ability to add hot water generation and air curtains to the system to enhance the efficiency of the building further by using the heat recovery effect, and these can also be set up as part of the same VRV system. Once a copy of the Daikin plugin for the virtual environment has been installed, an additional tab at the bottom of the screen appears where all the Daikin VRV system sizing and simulations will take place. On opening the plugin for the first time, you'll see that there are two tabs: Loads and Resizing, and a Thermal Simulation tab. Under the Loads and Resizing tab, you can select the type of system required for the project, and if there are multiple systems, then each of these can be configured to different types of system, depending on which type of application you are serving. 2-pipe systems for heating or cooling, and 3-pipe systems for heat recovery and simultaneous heating and cooling. You can also select the type of subsystem, for example, very high efficiency combinations, mini VRV systems, or heat recovery with hot water, amongst others. Other options allow you to select system oversize factors, the most common type of fan coil, selection methodology, and the load calculation type. From this point, a system selection can be made by clicking this button. Once the loads have been calculated, click on the selected condenser to show the grid selection, which shows all of the selected indoor units. In the grid are displayed the loads, the number of fan coils, the fan coil type, whether it's ducted or round flow cassette, the required fan speed, the unit size, pipe lengths and the available fan core capacities. And at the bottom is displayed the published efficiencies which are normally used for Part L compliance. It's worth noting at this point that all the deductions are already taken into account, for example, pipe losses, height differences and design conditions. Even modes like defrost and oil return are included at this point. Now that the system is selected, we can move into a full simulation which will calculate very accurately the power inputs for the Daikin VRV systems. During the simulation, the simulated loads are calculated and displayed, and then the power input for the VRV systems is then calculated, and the results are then displayed in the bottom right hand corner. A quick comparison on this example shows an increase above the published figures in heating from 3.37 to 5.78, and an increase in seasonal cooling performance from 6.24 to 6.74, with an overall system performance of 6.45. And these figures include the annual power input of all the associated indoor units, fan cores and branch selector boxes as required by Part L. These efficiencies are then backfilled into the systems that were created to service the building's temperature control requirements in the Apache Systems section of the VE. At Daikin, we believe that this plugin is the most accurate way of assessing the performance of VRV systems and represents a big step towards lowering carbon emissions in modern buildings by helping those responsible for the design of the building's energy requirements and the building services select the right solutions for the right projects. If you would like more information on the Daikin VRV Systems plugin, then please contact Daikin UK on 0845 641 9000 or by email at engineering@daikin.co.uk.